Hello! Shout out to my friends over at BCIT, British Columbia Institute of Technology. Hope everything's going well on the West Coast and you guys are safe over there. My friend Iqbal gave me an email to say, hey, we've got this homework assignment. It's a really cool homework assignment, but I need a little bit of help with that. Well, I can help you with that. It's a great assignment. What's going on is that this situation is a tank that's being filled. It's a pretty common example you'll see in a college to discuss a control situation. So what's happening here is that we've got some limit switches. So, pardon me, these guys are level switches specifically. Now let me actually just jump into JIC, the Joint Industry Council. So the symbols for limit switches in the Joint Industry Council are like this. This is the symbol for a normally open level switch, and this is the symbol for a normally closed level switch. This guy is going to go up over to there, and that's down there. So if liquid is below this, it'll be in its normal state. If liquid is above this, it will be in its active state. Same with this. Okay, it's just a different, this is a normally open and this is normally closed. So if we want to take a look at maybe the example of whether this is going to be open or closed, let's talk about that again. If liquid is below this level switch, it'll be in its normal state. Therefore, this normal state is closed because it's a normally closed. I'll just label it normally closed. Normally closed, and this guy is a normally open. So in its active state, it will be open. Okay, so when the liquid goes above it, it becomes open. This guy over here, when the liquid is below it, it's in its normal state and it's open. In its active state, when the liquid goes above it, it will become closed. So those are what the JIC says. The Joint Industry Council, JIC, they define what symbols look like for ladder logic. Okay, good. So let's continue. I'll get rid of that. And I just want to say, in this example, we're going to use normally closed. Oh, I just labeled that. I didn't write very well. Sometimes I do that. Okay, hold on a second here. That's a normally closed. Okay, hope you caught that. Okay, let's move on. So what we're going to do is we're going to use the normally closed, which actually helps us tremendously. If we were to use a normally open, it's going to cause a lot of problems, actually. We'd have to use a lot of holding circuits and stuff and maybe reverse some logic. But in this case, a normally closed is actually going to solve a lot of problems. So let's continue here and let's talk about this. Now, as far as turning this on and off, whatever, it's not so important. You can turn it on and off with a start-stop station. If you did use a start-stop station, of course, you could put your start button in there and then drive a relay. So a coiled relay 1, let's say. I can't write very well. Say a coiled relay 1, and from there that'd be fine. And then I could put a holding circuit on that from here. So that would be my R1-1. But the thing is, I would definitely need a termination contact in here. So I would put a normally closed push button. But you know what? In this case, I'm just going to say, well, whatever. We'll just put a toggle in here to turn everything on and off, just to make it simple. Maybe we'll even just say, if you just plug the thing in, it works. If you want it to stop, undo it. Because I don't want to get into adding the logic of how to turn it on and off, because that's actually just pretty simple. So what I'm going to do is just this. I'm going to say it's 24-volt system, and I'm going to go in here and I'm going to use a toggle switch. And then I'm going to put a power rail here, and we'll just work off of that power rail. We're going to put our logic in here. So I'm going to put my 0 here, and we'll put some logic in. Now, think about events. I need you to think about events. Just event. Think about event programming. So what event makes the pump come on? When the tank's full. Okay. What event makes the pump turn off when the tank's empty? Okay, that's cool. So now we know that the signal from this when it's empty is actually going to be high, right? Because it's when it's below this level switch, it'll be in its normal state, which is closed, so it'll give us a high signal. So that's actually pretty simple. Maybe we can actually just do this. In this case, I'm going to draw this guy, and this is my level switch, and it's the lower level switch, and maybe I can just drive my motor directly with that. How about that? Well, we know it's a little bit more complicated than that. Maybe we have to have this in there as well, but this actually shuts it off. Okay, well, there's also another situation where this is going to have to shut it on, turn it on as well, but we'll get there a little bit later. Okay, so let's just kind of work with this and see how this goes. Okay, now what's going to happen is that there's going to be a problem, because as soon as this goes above, as soon as the liquid goes above, so when it gets to this line here, this is going to go into its active state and become open. So you might want to hold on to that. Now, let me just kind of think a little bit further. If I just did this, I can tell that the pump would come on, it would stop there. I want it to keep going, okay? Now, there are a couple different ways to do that. And my first go-to, in my brain, my first go-to would to latch onto this, to put a memory latch onto this, to put a holding circuit onto this. Remember this event happened. Even if the event goes away, the memory latch is going to hold on to the action that that event originally made happen, which is turn the pump on. So that would be my first go-to. So let's actually just do that. If I did that, I'm going to go here. Now, you will see that I'm just going to use an R, so I'm going to say an R1. I'm going to say R1-1. Okay, now I got a holding circuit problem here. I have a termination contact that I got to put in there. Plus later on, I think we may end up seeing this as more complicated, and we may have to even change this. That's why you find yourself a whiteboard with some erasers, or you use a pencil, or you use a program to draw these things. Okay, good. So that's a situation that I can see that once it does get low and it goes above this, this will actually become open, but it's okay. I haven't lost that signal, or the signal went away, but I'm keeping the memory of it active with this relay. So that's fine. So the liquid goes above. Oh, look, there's my termination contact. Sweet. So I'm going to put the termination contact in here. Now, do I just put the switch in here? Let's just see if I can put that in there. I'm just going to draw it like this. It's a normally closed switch. And this is the level switch, the upper, or the high level switch. Okay, so when the liquid goes up, this will become open. Oh, sweet. Okay, good. So now the tank will just, it'll be full. Okay, good. Now, are we done? Well, there's actually more to it. There's a bunch more to it. And we'll end up changing this, actually, because it's actually simpler than this. The thing is, now we have to consider the whole action. If this guy gets full and then it gets low again, it's supposed to fill, okay? But in this situation, it will only fill if it gets all the way down to here. Now, I have an example that's very much like this, but in my example, it fills and then it empties, and then it fills and then it empties. But in this case, what's happening is that it's got to fill, and then if it gets a little bit low, it's got to fill again. A little bit low, it's got to fill again. So this has to maintain it. So what I've just discovered is there are two things that turn the pump on. There's the lower level switch and the upper level switch. They both should be turning the pump on, because once this will actually get this thing to go up here and stop. But if the liquid, for any reason, let's put some purple liquid in here. If the liquid, for any reason, went down to here, it could be that this is a tank that's, servicing something else, or whatever, supplying liquid, or maybe a mixed liquid or a heated liquid to some other system. Maybe we've got a drain that comes in here, and we want to keep it high. Lots of different reasons why this tank may empty. We don't want to get into that. We just want to talk about control. We've been told to keep this tank full. Okay, what do we do? Now, in this situation, I'm actually going to get my eraser, because I just realized, I won't even erase it. I'll just kind of do it again down here. And then I'm going to find that I'm going to change it again, but it's part of the process. Look, watch this. What if I did this? And I put my motor here, so I'm forgetting about this for now. And then if I did this, and this is going to be my level switch, the upper one, or the high one, and this is my level switch, my lower level switch. Now, let me draw this properly. It's normally closed, so this guy's got a touch here. Okay, good. So, now, in this case, if I just did this, so forget about this, what's going to happen is that it's okay if this signal disappears. I don't need a holding circuit anymore. Yeah, check it out. What's happening is that this piece of logic says, if this shows the tank is empty, or this shows the tank is not full, turn the pump on. You get that? Either or. So in this case, if this is low, that's closed, okay, that's closed, turns the pump on. When it goes above, the pump is going to shut off. But you know what? This is still in its normal state. Actually, technically, I won't even need this guy, the lower level switch. I don't even actually need it, but I'm going to keep it in there because the description tells me if it's empty, it's got to fill. So I have to leave that in there. Okay, good. So there, this is nice. I got this, and is that going to work? I think it'll kind of do one thing. It'll fill the tank and make sure that it's full. It kind of goes along a little bit more than that, because the description in here, which is a great description, I love this comment here. It's about an error. And the error is this. If this guy here shows that the tank is full, and that shows the tank is empty, then there's an error. And that error's got to shut the system down. It's got to shut it down. Okay, so what I can do is I can take this switch and put it together in some logic, and then actually maybe drive a relay with that, and then use that relay to do something else. Okay, that's cool. So can I do that? Oh, I can't do it. I'm using them here. I mean, I'm using my, I can't, can I somehow use this logic to answer that? No, I can't. What I need to do is I need to use relays. Connect the relays to each one of these and then use the contacts here. So let's do that. Actually, I got space for it up here because I realized I don't need this. Okay, let's go in here. And again, this is like the third time we're changing something. And that's okay because I'm using a whiteboard and I can erase stuff. You're going to constantly be redesigning stuff. In this case, I'm going to put my level switch here. Now, because I can't draw very well, I'm going to call this R1. Now, in this case, I'm going to put my level switch, my high level switch, and then I'm going to drive another relay with this guy, and that's my level switch, and that's my lower level switch. And I'm going to say R2. Now, over here, what I'm going to do is I'm just going to change these around, and I'm going to put contacts here. Now, should I put a normally open or a normally closed contact? Well, when do I want the signal? When do I want that? What event makes the motor turn on? Well, the event is when this gets low. Okay? When this gets low, what does this thing do? It closes. Okay? So, when the liquid is low, this will energize. Okay? I'm going to use a normally open. So that's my R1-1. And this guy is going to be my R2-1. Ooh, it's not a dash. -1. Okay, good. So, I've got the same logic, but I've also got this thing where I've got to add a piece of logic in that says, okay, if that shows full and that shows empty, what am I going to do? Okay, cool. And I think there's a light that's going to come on as well. Okay, so what's going to happen is that if a particular piece of logic becomes true, two things have to happen. One is we're going to shut the pump off. The other is we're going to turn the light on. Okay, so if something becomes true, how do you shut something off? Well, I mean, if I really wanted to, I'm just going to like go over here. Let's say I wanted to turn a light on if a switch becomes open. Okay, so here we go. I'm going to put a switch in here, and I want to turn a light on. So that's going to be my light 1. So this is a quick little ladder logic here, just one rung. If that becomes open, I want the light to turn on. Well, it's not going to work, right? So what do? Well, I just put a relay here. I put a relay there, and then I use a contact for my relay, and then I drive my light there. So this contact's actually going to be normally closed, because as soon as this goes into its open state, this will go to its normal state, or de-energized, and that'll go into its normal state, and it'll become closed. So the light will come on. So what I'm saying here is that there's this event, right? And it's an error in the system. And so obviously there's something wrong with this switch here, and that shows it's full and that shows it's empty, which is impossible. So if that logic is true, turn the light on and shut everything off. Well, the way to shut everything off is to reverse the logic. So what you need to do over here is you need to make a rung here, and that rung has to have the logic in it from this guy and from this guy that says this guy is in an open state and this guy is in a closed state. So what does that look like? Let me say that again. You have to put a piece of logic in here, and then that's going to be a relay. So that's going to be my R3. Okay, so I'm not going to tell you what that logic looks like. The logic is this. This guy is open. This guy shows the tank is full. This guy shows the tank is empty, and that means it's closed. So it's this. Ready? This is open, and this is closed. What did I say? And? Yeah. Okay, so work with that. Now, the thing is, what's going to happen here is that whatever this logic is going to look like, I want to hold on to it because, well, I want to do two things. One is I want to turn a light on. So that's fine. Actually, I could probably just do this, and I can put a light here. I'm going to call it light 1. So I could probably just put a light there, and whenever this energized, whenever that logic is true, this will energize and the light will come on. But I also want to close everything down. I want to shut things down. Hey, maybe I can just put a close. You know what? I can put a contact that can be my R3-1. I can just put a normally closed there. Because then what's going to happen then is that if this is true, if this becomes true, it'll just shut everything down. Will that work? Well, think about it. I'm not going to tell you if it'll work or not, but you may have something that pulses. Think about that. Okay, so actually we don't want to do that, so I'm actually going to take it off. But think about why that won't work. Think about what is actually going to happen. There may be some pulsing going on. Okay, good. So now the situation here is that I know this condition was true. So then if that condition is true, what I want to do is shut off the motor. Okay, so I'm going to shut the motor off with that condition by putting a contact over here to shut the motor off. And you figure out whether that's a normally open or normally closed contact and where it comes from. Now, the other thing is that to do that, I'm going to have to latch onto that. I think it's probably a good idea. The reason is because if you've got some kind of error, what you want to do is you want to make sure that it shuts down so that someone has to pay real good attention to be able to go in there and fix it. So you may actually want to have kind of a lockdown situation where you may want to put a contact in here to kill the termination, to terminate the holding circuit, because you want to latch onto that event and say, no, I'm holding on to this event. Nobody can do anything. That motor's not going to come on until the supervisor comes along, checks it, and he unlatches it. So maybe there's a key in here that will actually reset that holding circuit. Once actually he replaced this or he figured out what the problem was. So it's good if you have some kind of error or some kind of shutdown sequence to lock it in. So to say, no, nobody can turn this thing on, and to lock it down until the supervisor comes along or some specialist comes along and he's got maybe a secret key or he's got a code or he's got some way to reset the error. Okay, good. So there you go. I think that explains all of that, and thank you for that particular situation that I could share with everybody, and a shout out to BCIT. See ya.